Hello, my name is Charlie Grove. I'm the creator of ADIAT and the Director of Technology for Texas Search and Rescue. Before we start exploring some of the new features in version 1.6 of ADIAT, I want to take a moment to provide a little context and perspective as to what's been going on. Today is July 9th, 2025. Between July 4th and July 7th last week, a series of horrific storms came through central Texas, not far from here, and there has been utter devastation with loss of property and significant loss of life. To those who were directly impacted, injured, lost loved ones, or are still missing loved ones, I am truly sorry. Know that the community is still here for you. To the community who has been here and provided their unwavering support to those directly impacted and those who came in to help search, truly, thank you. Cannot express how grateful we are for everything you do for us. To my fellow first responders and searchers who came in to help with the search effort, it has been truly inspiring. This is unlike anything I have seen in my 12 years in search and rescue. Thank you all for being here, and please continue to be safe as you continue to search for those who are still missing. Finally, to my Texar coworkers, teammates, and friends, thank you for being a part of this organization. Thank you for giving back to the community. Thank you for being there for these families in their time of need. Please continue to be safe as we continue to search for those who are still missing. Now, for a bit of perspective, we're going to be looking at ADIAT, and we're going to be talking about the new features and new capabilities it possesses, but I don't want to lose sight of why ADIAT exists. This is not some thought exercise or experiment in what computer vision can do. This is an attempt to build a tool that can be utilized to help find missing people. It was built by search and rescue volunteers for the search and rescue community. It is no different than any other tool used for search and rescue. And just like all other avenues of search and rescue, we won't stop. We are continuing to build on ADIAT, not because we expect to at some point make money off of this or anything like that. We simply want to build better tools that can be utilized to help reunite families and bring resolution to families. So thank you very much for joining us. Thank you for your interest in ADIAT, and thank you for continuing to be part of the search and rescue community. Let's go ahead and jump into our version 1.6 exploration. So in version 1.6 of ADIAT, we've introduced a brand new algorithm that is actually our first AI-based algorithm. I'm very excited about that, and we'll talk a little bit more about what that means here in a second. We've also added a new variant of one of our existing algorithms that we'll talk about, as well as some enhancements to the viewer experience. So before we talk about the AI algorithm, let's talk about the new variant of the color range algorithm. And this is one where instead of playing in the RGB color model that we've been using thus far, we're actually going to be looking at the HSV color model and taking a look at what that means. So RGB, it's kind of the native language for screens and cameras. It's the three color channels, blue, red, and green. You pick a value between 0 and 255 for each of those channels, and those three combine to build the color for you. So it's native to basically what all screens and cameras use. It's simple for devices, and then it's straightforward for the computers and hardwares to understand and digest. Whereas on the HSV side, it's a little less intuitive for the computer, but it's actually much more intuitive for humans to understand. So the way HSV works, you can see in our diagram here, hue is essentially what color are you picking? Is it blue? Is it red? Is it purple? Is it yellow? Saturation is how intense is that color? Is it faded out? Is it super vibrant? And value is how bright is that color. And those three combine to put together pretty much the same number of colors as RGB. So looking at the advantages of HSV, much more intuitive. You can say, I want all the bright colors or I want all the greens, etc., and we can pull those out. And it's much easier to just pick a color. You can just look at basically the hue range and say, I want red or I want green or I want some combination. And then you go into kind of the nuances of, do you want it stronger or weaker? Do you want it brighter or darker? If we look at that, and finally, it's better for searching for colors because, again, we're saying, hey, show me all the things that are red on the hue slider there. If we look at that in our color selector, so if we're looking over here on the right side, we have our hue basically going across. We have saturation, again, how intense is that color? And then value is going to be over here and basically selecting the brightness. Much like we can select our RGB values down here as before, we can do the same thing with hue, saturation, and value if you want to go ahead and provide those numbers directly. And of course, if you still want to set your color using RGB or HTML hex code value, you can do that and it will automatically be converted to a HSV value. We'll take a look at what that algorithm looks like in the interface here in a moment. But before we move on, I do want to say again, thank you very much to John O'Keefe from El Dorado SAR out in California for implementing that variant of the color range algorithm for us. Moving on, let's talk about the AI Person Detector algorithm. So we are super excited about this one. I'm super excited about this one. This is our first AI algorithm that has been introduced in ADIAT. So thus far, everything we've talked about is kind of traditional computer vision. We're looking for color variations or color anomalies or things of that nature. Nothing that really depends on the computer's ability to determine what sort of objects are present in the image. That changes with the AI Person Detector algorithm, which, as the name would imply, is specifically trained to detect people in an image. So how do you build an object detector model like this? Well, the very high level version of it is first you prepare the data. You gather a huge set of images where the object that you're looking for is present and some images where they're not present. So you have your negative image set. In our case, those are all images that include people. Specifically for our use case, we want images taken from drones and other aerial cameras. So it's kind of that same environment that we're going to be using for our detector. So it gets used to seeing people as you see it from a drone, because just having pictures of people from straight on at ground level doesn't really give the algorithm what it needs to learn how to actually identify a person in an aerial photo. Because as you can imagine, and as you know, if you take a picture of a person in a selfie versus the person of a picture from a drone at 200 feet, they look drastically different. So we need images that are representative of the images we are going to use for detection. Once we take all those images, they need to be annotated. So someone needs to go in and literally draw boxes around all the people in those images so that the algorithm can learn, looking at those images, hey, this box here or something in this box here that represents the object that I'm looking for, in our case, a person. So we have to go into all those images that include people and draw the boxes around them so that the algorithm can take that information and learn from it and then extrapolate as it goes to see new examples where we haven't done the annotation, say, hey, this looks a lot like what I've learned from looking at all these other images, so I'm going to make a prediction that this is in fact a person in this new image. And that's what it does in step 3. That's where it does the actual training. We take in all those images and it goes through multiple iterations of learning, going through all of those image sets and breaking them down and doing things to basically, again, it's artificial intelligence. It's kind of like how you would teach anything or anyone something new. It goes through the training exercises of learning from repetition and learning from examples that this is what represents a person in an image. So it looks at those examples that we annotated and it learns from that. And finally, we use that trained model to go ahead and make predictions. So once the model has been trained, we look at the data that comes out of it, the results. We're comfortable with the accuracy, the precision, and recall are the two main metrics, which basically amount to true positives and false negatives. Once we're comfortable with those, we go ahead and implement the model, and we ask it to start making predictions of its own. So a little bit more about the image annotation side of this. So as I mentioned, image annotation is the process of going in and, as you see here, taking the images and going ahead and actually drawing the boxes around the objects that we want the algorithm to eventually be able to identify on its own. This is a very time-consuming and tedious process because not only do you have to collect all these images, in our case, take the images from a drone, you also have to go in and manually do all this tagging. And thankfully, there are groups out there that have done that legwork for us and been nice enough to make their data sets available to the public for use for exercises like ours in building our algorithm for ADIAT. In the case of ADIAT, we used 3 publicly available datasets. We used the Herodol dataset, we used the SARD dataset, which is specific for search and rescue. Actually, I believe all 3 of these were specifically designed for search and rescue. So Herodol, SARD, and Wizard. Uh, Again, those teams did the incredible amount of legwork to make these images available and did the actual annotations. And without them, we would be months behind because we would have to source all the images from different environments and different drones and different conditions with people in different poses and all those things, that whole holistic set of images and situations you need to be able to provide the information to the algorithm so that it can correctly make predictions for images from different environments. Now, once the images have been annotated, there's a little bit more prep work that has to be done before they can be used by our algorithm, and this speaks to image size and resolution. So when we talk about image size or resolution, we're strictly talking about how much information there is in the image. There's sometimes a misconception that when we talk about moving from one image size to another, so moving from something like 48 megapixels to 20 megapixels, there's a misconception that it changes the field of view. That doesn't happen. It's simply an exercise in resizing the image. So as an example, if we look at this picture, this was sliced from a picture that was 8,000 pixels by 6,000 pixels, so a 48 megapixel image. We can clearly see there's a person in the image. If we were to change the image resolution or resize that image down to 640 by 640, it's really hard to tell what that is, and I don't think it would be there would be any way where an algorithm would justifiably say, oh yeah, that's clearly a person in this picture down here. Why does that matter to us? Because AI models are typically trained to make predictions on images that are only 640 by 640 pixels, which is way smaller than any of the images that drones capture these days. So before we can use these images to train our model, we have to find a way to break them down without losing the fidelity of the image or the details in the image. And we do that through a process called image slicing. And what we're doing with image slicing is literally just tiling the image, but doing it in a way that we still have overlaps between the sections of the image, just in case our person you see here happened to be right on the border between 2 slices or would be split between 2 slices. We don't want to lose the fact that the person's there, so we would rather have the overlap and have them show in both slices rather than either slice or partially in 2 slices, if that makes sense. So this is what it looks like if we were to slice this image down from its 48 megapixel original size to, I believe I set this to 1280 by 1280 boxes. And 1280 by 1280 is small enough that we can then resize down to 640 by 640 for the training process for the algorithm. So we take our full-size images, we slice them down to 640 by 640, and then we run them through the training process in that algorithm. Once we're comfortable with the results, then we go ahead and use it to make predictions. And when we're going to make predictions, we do the same thing. We go ahead and slice the input images that you put into ADIAT down to 1280 by 1280, and then they get resized from there down to 640 by 640. Why don't we just slice down to 640 by 640? It's really a matter of time. If we slice down to 640 by 640, there's just so many slices to push through and make predictions that it's just not economical time-wise. So we found it going down to 1280 by 1280 and then resizing from there. We still have enough fidelity in the image to make the predictions and be comfortable with the results. Now, the downsides to AI. So, AI is obviously still fairly new in the industry and in the marketplace, and it is not without its complexity when getting things set up. So, for most end users, the process can be a little daunting. We've provided a guide on the ADIAT page to help get you set up. But for it to be as efficient as possible, there's a little bit of legwork that has to be done before installing ADIAT, and there's some hardware requirements that complicate the process a little bit as well. And to that end, if you're not able to leverage, and this is, again, I fully understand this is not going to go way over the heads of some folks, which is fine, but just understand that for an AI model to be run efficiently, it needs to be run on the GPU, which is essentially your video card, instead of just on the CPU, which may not be intuitive, but there's all sorts of technical reasons why. And you see what the difference is here on the right side. So when we're using a GPU, RTX 5080, which is pretty close to the top end for a consumer GPU these days, running 234 images that were 48 megapixels each, takes 94 seconds. Whereas if we run it on the CPU in the same computer, which again, pretty close to top of the line for a consumer system these days with 24 cores, it's taking a full 335 seconds. And as you can imagine, as the hardware gets a little less advanced, the process takes considerably longer. So just something to be aware of. If you're going to leverage the AI algorithms, there's a little bit of setup that needs to be done up front, and your results will come back a whole lot faster if you're able to leverage a GPU to do that processing. Again, we have a guide on the ADIAT website to help you get that set up. If you have questions through that setup process, please feel free to reach out. We're happy to help where we can. The other aspect of this is that the libraries to do those predictions can take up a lot of extra space on your hard drive. Not a crazy amount. We're not talking, 10 gigabytes, 5 gigabytes, anything like that, but it definitely increases the overall size of the ADIAT application or the footprint of the ADIAT application on your hard drive. So to that end, we're actually going to make two variants of version 1.6 available, one with AI, the AI algorithm, and one without the AI algorithm. And that's so if you're not in a place where you don't have a system where you think it's really going to be able to make use of the AI algorithm, that is totally fine. We're not going to penalize you for that. We're going to make every other feature of ADIAT still available to you, including the new ones that are introduced, but we won't penalize you and make you install this extra large application that is taking up extra room on your hard drive. With that, let's jump over to ADIAT itself and take a look at these two new algorithms as well as the advancements in the viewer interface. Over in ADIAT now, see that the main window has remained largely unchanged since version 1.5. Up at the top, we have our input and output folder selections. We have our min object area. We have the opportunity to set a max object area. We have our identifier color and our max number of processes. We also have our two advanced features, k-means clustering and histogram normalization. Then we have our algorithm selector and our algorithm specific parameters down here. And we have our button bar with our start, cancel, and view results button and our console at the bottom. Looking at our new algorithm, and you will note that we did slightly rename the original color range algorithm, so now it's color range RGB, and the new variant is color range HSV. When we select that, you can go ahead and click on the Pick Color button. It picks up our standard color selector, same one that we use for the color range RGB algorithm and the match filter algorithm. So we can go ahead and select our color here, the same way we have always done, and then bring this over so we can see, again, the reminder of how the hue, saturation, and value are depicted here. So hue is going across horizontally, saturation is vertically inside this block here, and then the value, which is the brightness, is controlled over here on the right side. Now, one thing that is maybe a little strange is saturation and value are on a scale of 0 to 255 with the library we use. Hue is actually on a scale of 0 to 179, so there's 180 possible values. And if the range gets to 0 or 180, it will actually roll around back to the other side. So because the hue selector is essentially a circle at that point. So we can select a value of, in this case, we select our hue saturation range value, and then we can go ahead and set our range. Let's make the range 40, saturation range 75, and let's do the same for the value range. And then we can go into our range viewer, the same viewer we have for the other color range algorithm, as well as match filter. And that'll show us which portion of this color map is going to be considered a match to the color we're looking for. And seeing that hue range, I'm actually going to drop that down just so we don't get way more positives than we're hoping for here. So let's select that, go ahead and hit start, and we will process our sample image set of 158 images. Performance is consistent with the color range RGB algorithm. Different computer than the ones I've been using for previous demonstrations. It's a little bit faster. So in this case, we ran 158 images in 5.7-ish seconds with 33 images with areas of interest identified. I'm going to go ahead and go into the results viewer now, and we'll talk about some of the enhancements in the viewer, and then we'll come back and look at the AI algorithm. So in the results viewer, you'll notice a few new things. So we have a show overlay toggle here at the top, and that toggles this little overlay down here, which shows us two things. One, the direction of orientation of the drone when the image was taken. So when you're trying to ground truth the image or overlay it or try to line it up with a satellite view or something like that, just gives you a sense of direction so you know which way is north in the image. We also have a scale here which is based on our average GSD or ground sampling distance. Now, there's a whole video about how ground sampling distance is calculated and how it's impacted by the angle of the gimbal camera. You are more than welcome to check out that video for more information. But note that the scale that is provided here is a rough estimate based on the average GSD going across the whole image. And if we go ahead and zoom in to an area like this, we'll see that the GSD scale here, or the scale here, changes with us as we zoom. Those are the big changes on the image viewer itself. A couple of things that are back in the main interface that impact this. So one, if we go into the menu, we can look at the preferences. We can set our distance unit. So we can say, do we want it in feet or do we want it in meters? And of course, I'll use centimeters if the scale gets small enough. You'll also see there is a drone sensor file version down here. And this gets us squarely into the this shouldn't be this hard category. So when we're doing those GSD calculations, you may remember from a previous video, there's a few attributes that we need that aren't readily available in the metadata, namely the physical sensor size for the camera when it's taking the picture. And if we look at a metadata viewer, this is the EXAF tool GUI. We see, as I said, that sensor information isn't available to us, but there's some other things we can use as context clues and basically have a lookup externally to say, hey, this camera, this model has this sensor size. We just basically have a spreadsheet. Now where things get complicated, of course, for whatever reason, when the drone manufacturers put the drone or camera information in the files, it is somewhat cryptic. So this is a DJI Air, and the information that's actually captured in the image is it's a DJI FC2103. So there's a whole exercise that went on to try to figure out what all the different drone manufacturers called their various cameras in the metadata so that we could pull our basically decoder ring together and say, okay, if I see DJI FC2103, I know it's a DJI Air. I can go look up the sensor size for the DJI Air and make my GSD calculations. And likewise, as we look through some of these, again, it's a whole thing. It gets way more complicated than you would expect. So like something like the Matrice 4T, which has multiple cameras. They're nice enough to actually put the model here, but then we have to use other attributes in here to identify which of its 3 cameras it's actually using for that particular image. Why is this important to you? Because as new drones are added, or there's always the potential that we maybe mislabeled something in our dictionary, we may need to create new versions of this drone sensor file, and we will make that file available on the ADIAT website. If for some reason your GST calculations aren't showing up in your images, go ahead and check the ADIAT website and see if there's a new version of this file available. Easy enough to replace. You just hit replace here and select the new file, hit open. It'll automatically replace the old one with the new one, and if it has the updated information, you will see that those GST calculations in the viewer. Switching over to the AI Person Detector. Fairly boring parameters to choose from here. So there's really only one parameter you're setting. It is simply the confidence threshold, which is saying, hey, how confident does the algorithm need to be that it is seeing, in our case, a person, which is the one class that we have it looking for. So we say, is it 50%, is it 60%, 70%, etc. The other thing we have down here is, again, to try to simplify as much as possible that process of getting the hardware set up to leverage the GPU. We do some checks in the background to make sure that everything is set up and configured in a way that ADIAT can go ahead and leverage that GPU. You can click on the requirements, and we have the instructions there as well, and a link to the official document for additional information. So I'm going to run this actually on a different image set. So run it on this one, and we'll use the same output folder for now. I'm going to increase the min object area because we're not just looking for evidence at this point, we're only looking for a whole person. So I'm going to set my min object area to 100, and I will go ahead and start. And this will take a little longer than some of our other algorithms because it is doing that AI processing in the background. So I will go ahead and pause the video here and come back when it finishes. All right, 90 seconds later, we are back. Our algorithm has finished running, looking for people in this image set. Out of 234 images, it found 35 with areas of interest. That is, areas that it determined to be a person with at least a 50% level of confidence. If we go into the viewer, we will see our first false positive, not unexpected. So again, these algorithms are still fairly new, and we will continue to refine them. And the more data sets we have, the larger the data set we have, the more accurate it will get in its predictions. The good news is, as these data sets become available, we can provide new versions of just the model without having to release a whole new version of ADIAT. So much like we'll have the drone sensor information available on the website as kind of an evergreen file that we keep updating, we'll also provide new versions of the person detector model, which you can just drop into the program file and run. But while we do have a false positive here and a few false positives to get kicked off, we do see here that it did in fact identify the person correctly in all these other images later in the image set, which is pretty exciting. So yeah, it is finding a person. It is doing exactly what we trained it to do, and we hope you find that as exciting and valuable as we do. That finishes our look at the current set of features in version 1.6 of ADIAT. Before we leave, I do want to tee up the next video that we're going to be doing. For our next video, we are going to go back to the basics. So there was a request on social media somewhere, someone is saying, hey, these videos are great, but they definitely get down to the weeds and talking about how the sausage is made. We just want one video that teaches us how to use ADIAT if you're coming in as a complete new user. And that's what our next video will do. We're going to take this decision tree that we put together and use this as the basis for our video. walking through the various scenarios and instances where you would want to use ADIAT and help you decide which algorithm to use and what parameters to use to get the most out of ADIAT. So look forward to seeing you next time. Thank you again for your interest in ADIAT, and please feel free to always reach out if anything comes up, if you have any feedback or anything else. Thank you very much.